We started OpenAI 7 years ago because we felt like something really interesting was happening in AI, and we wanted to help steer it in a positive direction. It's honestly just really amazing to see how far this whole field has come since then. And it's really gratifying to hear from people like Raymond, who are using the technology we are building and others for so many wonderful things. We hear from people who are excited. We hear from people who are concerned. We hear from people who feel both those emotions at once. And honestly, that's how we feel. Above all, it feels like we're entering an historic period right now, where we as a world are going to define a technology that will be so important for our society going forward. And I believe that we can manage this for good. So today I want to show you the current state of that technology and some of the underlying design principles that we hold dear. So the first thing I'm going to show you is what it's like to build a tool for an AI rather than building it for a human. So we have a new DALL-E model which generates images, and we are exposing it as an app for ChatGPT to use on your behalf. And you can do things like ask, suggest a nice post-TED meal and draw a picture of it. Now, you get all of the sort of ideation and creative back and forth and taking care of the details for you that you get out of ChatGPT. And here we go. It's not just the idea for the meal, but very, very detailed spread. So let's see what we're going to get. But ChatGPT doesn't just generate images in this case. Sorry, it doesn't generate text. It also generates an image. And that is something that really expands the power of what it can do on your behalf in terms of carrying out your intent. And I'll point out, this is all a live demo. This is all generated by the AI as we speak, so I actually don't even know what we're going to see. This looks wonderful. Now I'm getting hungry just looking at it. Now, we've extended ChatGPT with other tools too. For example, memory. You can say, save this for later. And the interesting thing about these tools is they're very inspectable. So you get this little pop-up here that says, use the DALL-E app. And by the way, this is coming to all ChatGPT users over upcoming months. And you can look under the hood and see that what it actually did was write a prompt, just like a human could. And so you sort of have this ability to inspect how the machine is using these tools, which allows us to provide feedback to them. Now, it's saved for later, and let me show you what it's like to use that information and to integrate with other applications too. You can say, now make a shopping list for the tasty thing I was suggesting earlier. I'm going to make it a little tricky for the AI. And tweet it out for all the TED viewers out there. So if you do make this wonderful, wonderful meal, I definitely want to know how it tastes. But you can see that ChatGPT is selecting all these different tools without me having to tell it explicitly which ones to use in any situation. And this, I think, shows a new way of thinking about the user interface. Like, we are so used to thinking of, well, we have these apps, we click between them, we copy-paste between them, and usually it's a great experience within an app as long as you kind of know the menus and know all of the options. Yes, I would like you to. Yes, please. Always good to be polite. And by having this unified language interface on top of tools, the AI is able to sort of take away all those details from you. So you don't have to be the one who spells out every single sort of little piece of what's supposed to happen. And as I said, this is a live demo, so sometimes the unexpected will happen to us. But let's take a look at the Instacart shopping list while we're at it. And you can see we sent a list of ingredients to Instacart. Here's everything you need. And the thing that's really interesting is that the traditional UI is still very valuable, right? If you look at this, you still can click through it and sort of modify the actual quantities. And that's something that I think shows that they're not going away, traditional UIs. It's just we have a new augmented way to build them. And now we have a tweet that's been drafted for our review, which is also a very important thing. We can click run, and there we are. We're the manager. We're able to inspect. We're able to change the work of the AI if we want to. And so after this talk, you will be able to access this yourself. And there we go. Cool. So, thank you, everyone. So we'll cut back to the slides. Now, the important thing about how we build this, it's not just about building these tools. It's about teaching the AI how to use them. Like, what do we even want it to do when we ask these very high-level questions? And to do this, we use an old idea. If you go back to Alan Turing's 1950 paper on the Turing test, he says, look, you'll never program an answer to this. Instead, you can learn it. You could build a machine like a human child and then teach it through feedback. Have a human teacher who provides rewards and punishments as it tries things out and does things that are either good or bad. And this is exactly how we train ChatGPT. It's a two-step process. First, we produce what Turing would have called a child machine through an unsupervised learning process. We just show it the whole world, the whole internet, and say, predict what comes next in text you've never seen before. And this process imbues it with all sorts of wonderful skills. For example, if you're shown a math problem, the only way to actually complete that math problem, say what comes next, that green 9 up there, is to actually solve the math problem. But we actually have to do a second step too, which is to teach the AI what to do with those skills. And for this, we provide feedback. We have the AI try out multiple things, give us multiple suggestions, and then the human rates them, says this one's better than that one. And this reinforces not just the specific thing that the AI said, but very importantly, the whole process that the AI used to produce that answer. And this allows it to generalize. It allows it to teach, to sort of infer your intent and apply it in scenarios that it hasn't seen before, that it hasn't received feedback. Now, sometimes the things we have to teach the AI are not what you'd expect. For example, when we first showed GPT-4 to Khan Academy, they said, wow, this is so great. We're going to be able to teach students wonderful things. Only one problem, it doesn't double-check students' math. If there's some bad math in there, it will happily pretend that 1 + 1 = 3 and run with it. So we had to collect some feedback data. Sal Khan himself was very kind and offered 20 hours of his own time to provide feedback to the machine alongside our team. And over the course of a couple months, we were able to teach the AI that, hey, you really should push back on humans in this specific kind of scenario. And we've actually made lots and lots of improvements to the models this way. And when you push that thumbs down in ChatGPT, that actually is kind of like sending up a bat signal to our team to say, here's an area of weakness where you should gather feedback. And so when you do that, that's one way that we really listen to our users and make sure we're building something that's more useful for everyone. Now, providing high-quality feedback is a hard thing. If you think about asking a kid to clean their room, if all you're doing is inspecting the floor, you don't know if you're just teaching them to stuff all the toys in the closet. This is a nice Dolly-generated image, by the way. And the same sort of reasoning applies to AI. As we move to harder tasks, we will have to scale our ability to provide high-quality feedback. But for this, the AI itself is happy to help. It's happy to help us provide even better feedback and to scale our ability to supervise the machine as time goes on. And let me show you what I mean. For example, you can ask for GPT-4 a question like this of how much time passed between these two foundational blogs on unsupervised learning and learning from human feedback, and the model says 2 months passed. But is it true? Like, these models are not 100% reliable, although they're getting better every time we provide some feedback. But we can actually use the AI to fact check it, and it can actually check its own work. You can say, fact check this for me. Now, in this case, I've actually given the AI a new tool. This one is a browsing tool where the model can issue search queries and click into web pages. And it actually writes out its whole chain of thought as it does it. It says, I'm just going to search for this, and it actually does the search. It finds the publication date in those search results. It then is issuing another search query. It's going to click into the blog post. And all of this you could do, but it's a very tedious task. It's not a thing that humans really want to do. It's much more fun to be in the driver's seat, to be in this manager's position, where you can, if you want, triple check the work. And out come citations, so you can actually go and very easily verify any piece of this whole chain of reasoning. And it actually turns out 2 months was wrong, 2 months and 1 week. That was correct. we'll cut back to the slide. And so the thing that's so interesting to me about this whole process is that it's this many-step collaboration between a human and an AI, because a human using this fact-checking tool is doing it in order to produce data for another AI to become more useful to a human. And I think this really shows the shape of something that we should expect to be much more common in the future, where we have humans and machines kind of very carefully and delicately designed in how they fit into a problem and how we want to solve that problem. We make sure that the humans are providing the management, the oversight, the feedback, and the machines are operating in a way that's inspectable and trustworthy. And together, we're able to actually even create even more trustworthy machines. And I think that over time, if we get this process right, we will be able to solve impossible problems. And to give you a sense of just how impossible I'm talking, I think we're going to be able to rethink almost every aspect of how we interact with computers. For example, think about spreadsheets. They've been around in some form since, we'll say 40 years ago with VisiCalc. I don't think they've really changed that much in that time. And here is a specific spreadsheet of all the AI papers on the archive for the past 30 years. There's about 167,000 of them. And you can see the data right here. But let me show you the ChatGPT take on how to analyze a data set like this. So we can give ChatGPT access to yet another tool, this one, a Python interpreter, so it's able to run code, just like a data scientist would. And so you can just literally upload a file and ask questions about it. And very helpfully, it knows the name of the file, and it's like, oh, this is CSV, a comma separated value file. I'll parse it for you. The only information here is the name of the file, the column names like you saw, and then the actual data. And from that, it's able to infer what these columns actually mean. Like that semantic information wasn't in there. It has to sort of put together its world knowledge of knowing that, oh yeah, archive is the site that people submit papers, and therefore that's what these things are, and that these are integer values, and so therefore it's a number of authors in the paper. Like all of that, that's work for a human to do, and the AI is happy to help with it. Now, I don't even know what I want to ask. So fortunately, you can ask the machine, can you make some exploratory graphs? And once again, this is a super high-level instruction with lots of intent behind it, but I don't even know what I want, and the AI kind of has to infer what I might be interested in. And so it comes up with some good ideas, I think. So a histogram of the number of authors per paper, time series of papers per year, word cloud of the paper titles. All of that, I think, will be pretty interesting to see. And the great thing is, it can actually do it. Here we go, a nice bell curve. You see that 3 is kind of the most common. It's going to then it's going to make this nice plot of the papers per year. Something crazy is happening in 2023, though. It looks like we were on an exponential and it dropped off a cliff. What could be going on there? And by the way, all this is Python code you can inspect. And then we'll see the word cloud. And so you can see all these wonderful things that appear in these titles. But I'm pretty unhappy about this 2023 thing. It makes this year look really bad. Of course, the problem is that the year's not over. So I'm going to push back on the machine. So April 13th was the cutoff date, I believe. Can you use that to make a fair projection? So we'll see. This is a kind of ambitious one. So, again, I feel like there was more I wanted out of the machine here. I really wanted it to notice this thing. Maybe it's a little bit of an overreach for it to have sort of inferred magically that this is what I wanted. But I inject my intent. I provide this additional piece of sort of guidance. And under the hood, the AI is just writing code again. So if you want to inspect what it's doing, it's very possible. And now it does the correct projection. And if you notice, it even updates the title. I didn't ask for that, but it knows what I want. Now, we'll cut back to the slide again. This slide shows a parable of how I think a vision of how we may end up using this technology in the future. A person brought his very sick dog to the vet, and the veterinarian made a bad call to say, let's just wait and see. And the dog would not be here today had he listened. in the meanwhile, he provided the blood test, like the full medical records, to GPT-4, which said, I am not a vet, you need to talk to a professional, here are some hypotheses. He brought that information to a second vet who used it to save the dog's life. Now, these systems, they're not perfect. You cannot overly rely on them. But this story, I think, shows that the human with a medical professional and with ChatGPT as a brainstorming partner was able to achieve an outcome that would not have happened otherwise. I think this is something we should all reflect on and think about as we consider how to integrate these systems into our world. And one thing I believe really deeply is that getting AI right is going to require participation from everyone. And that's for deciding how we want it to slot in. That's for setting the rules of the road for what an AI will and won't do. And if there's one thing to take away from this talk, it's that this technology just looks different. It's just different from anything people had anticipated. And so we all have to become literate. And that's honestly one of the reasons we released ChatGPT. Together, I believe that we can achieve the OpenAI mission of ensuring that artificial general intelligence benefits all of humanity. Thank you.
Greg, wow. I mean, I suspect that within every mind out here, apart from there's a feeling of reeling. Like I suspect that a very large number of people viewing this, you look at that and you think, oh my goodness, pretty much every single thing about the way I work, I need to rethink. Like there's just new possibilities there. Am I right? Who thinks that they're having to rethink the way that we do things? Yeah, I mean, it's amazing, but it's also really scary. So let's talk, Greg. Let's talk. We have
Absolutely.
I mean, I guess my first question actually is just how the hell have you done this? You know, like OpenAI has a few hundred employees. Google has thousands of employees working on artificial intelligence. Why is it you who's come up with this technology that shocked the world?
Yeah, well, I mean, the truth is we're all building on shoulders of giants, right? There's no question if you look at the compute progress, the algorithmic progress, the data progress, all of those are really, really industry-wide. But I think within OpenAI, we made a lot of very deliberate choices from the early days. And the first one was just to confront reality as it lays. And, you know, that we just sort of like thought really hard about, like, what is it going to take to make progress here? We tried a lot of things that didn't work, so you only see the things that did. And I think that the most important thing has been to get teams of people who are very different from each other to work together harmoniously.
Can we have the water, by the way, just brought here? I think we're going to need it. It's a dry mouth topic. But isn't there something also just about the fact that you saw something in these language models that meant that if you continued to invest in them and grow them, that something at some point might emerge?
Yes. And I think that, I mean, honestly, I think the story there is pretty illustrative, right? I think that at a high level, deep learning, like we always knew that was what we wanted to be, was a deep learning lab. And exactly how to do it, like I think that in the early days, we didn't know. We tried a lot of things, and one person was working on training a model to predict the next character in Amazon reviews, and he got a result where this is a syntactic process. You expect, you know, the model will predict where the commas go, where the nouns and verbs are, but he actually got a state-of-the-art sentiment analysis classifier out of it, that this model could tell you if a review is positive or negative. And I mean, today we were just like, oh, come on, like anyone can do that. But this was the first time that you saw this emergence, this sort of semantics that emerged from this underlying syntactic process. And there we knew, you got to scale this thing, you got to see where it goes.
So I think this helps explain the riddle that baffles everyone looking at this, because these things are described as prediction machines. And yet what we're seeing out of them just feels impossible that could come from a prediction machine, just the stuff you showed us just now. And the key idea of emergence is that when you get more of a thing, suddenly different things emerge. It happens all the time. Ant colonies, single ants run around. When you bring enough of them together, you get these ant colonies that show completely emergent and different behavior. Or a city where a few houses together, it's just houses together. But as you grow the number of houses, things emerge like suburbs and cultural centers and traffic jams. Give me one moment for you when you saw just something pop that just blew your mind, that you just did not see coming.
Yeah, well, so if you can try this in ChatGPT. If you add 40-digit numbers,
40-digit
numbers, the model will do it, which means it's really learned a internal circuit for how to do it. And the really interesting thing is actually if you have it add like a 40-digit number plus a 35-digit number, it'll often get it wrong. And so you can see that it's really learning the process, but it hasn't fully generalized, right? It's like you can't memorize the 40-digit addition table. That's more atoms than there are in the universe. So it had to have learned something general, but that it hasn't really fully yet learned that, oh, I can like sort of generalize this to adding arbitrary numbers of arbitrary lengths.
So what's happened here is that you've allowed it to scale up and look at an incredible number of pieces of text, and it is learning things that you didn't know that it was going to be capable of learning.
Well, yeah, and it's more nuanced too, because so one science that we're starting to really get good at is predicting some of these emerging capabilities. And to do that, actually, one of the things that I think is very undersung in this field is sort of engineering quality. Like we had to rebuild our entire stack and get, like when you think about building a rocket, like every tolerance has to be like incredibly tiny. Same is true in machine learning. You have to get every single piece of the stack engineered properly. And then you can start doing these predictions. There are all these incredibly smooth scaling curves, which I think tell you something deeply fundamental about intelligence. If you look at our GPT-4 blog post, you can see all of these curves in there. And now we're starting to be able to predict. So we were able to predict, for example, the performance on coding problems from, we basically look at some models that are 10,000 times or 1,000 times smaller. And so there's something about this that is actually smooth scaling, even though it's still early days.
So here is one of the big fears then that arises from this. If it's fundamental to what's happening here, that as you scale up, things emerge that you can maybe predict in some level of confidence, but it's capable of surprising you. Why isn't there just a huge risk of something truly terrible emerging?
Well, I think all these are questions of degree and scale and timing. And I think one thing people miss too is sort of the integration with the world is also this like incredibly emergent, like sort of very powerful thing too. And so that's one of the reasons that we think it's so important to deploy incrementally. And so I think that what we kind of see right now, if you look at this talk, a lot of what I focus on is providing really high quality feedback. Today, the tasks that we do, you can inspect them, right? That it's very easy to look at that math problem and be like, no, machine, like 7 was the correct answer. But even summarizing a book, like that's a hard thing to supervise. Like, how do you know if this book summary is any good? You have to read the whole book. No one wants to do that. And so I think that the important thing will be that we take this step by step and that we say, okay, as we move on to book summaries, we have to supervise this task properly. We have to build up a track record with these machines that they're able to actually carry out our intent. And I think we're going to have to produce even better, more efficient, sort of more reliable ways of scaling this sort of like making the machine be aligned with you.
So we're going to hear later in the session, there are critics who say that, there's no real understanding inside. The system is going to always, we're never going to know that it's not generating errors, that it doesn't have common sense and so forth. Is it your belief, Greg, that is true at any one moment, but that the expansion of the scale and the human feedback, that you talked about is basically going to take it on that journey of actually getting to things like truth and wisdom and so forth with a high degree of confidence? How can you be sure of that?
Yeah, well, I think that the OpenAI, the short answer is yes, I believe that is where we're headed. And I think that the OpenAI approach here has always been just like let reality hit you in the face, right? It's like this field is the field of broken promises of all these experts saying X is going to happen, Y is how it works. People have been saying neural nets aren't going to work for 70 years. They haven't been right yet. They might be right, maybe 70 years plus 1 or something like that is what you need. But I think that our approach has always been you've got to push to the limits of this technology to really see it in action, because that tells you then, oh, here's how we can move on to a new paradigm. And we just haven't exhausted the fruit here.
It's quite a controversial stance you've taken, that the right way to do this is to put it out there in public and then harness all this, instead of just your team giving feedback, the world is now giving feedback. But if bad things are going to emerge, it is out there. So the original story that I heard on OpenAI when you were founded as a nonprofit, where you were there as the great sort of check on the big companies doing their unknown, possibly evil thing with AI, and you were going to build models that sort of somehow held them accountable and was capable of slowing the field down if need be, or at least that's kind of what I had. And yet what's happened, arguably, is the opposite, that your release of GPT, especially ChatGPT, sent such shockwaves through the tech world that now Google and Meta and so forth are all scrambling to catch up. And some of their criticisms have been, you are forcing us to put this out here without proper guardrails, or we die. You know, how do you make the case that what you have done is responsible here and not reckless?
Yeah, we think about these questions all the time, like seriously all the time. And I think that I don't think we're always going to get it right. But one thing I think has been incredibly important, like from the very beginning when we were thinking about how to build artificial general intelligence, actually have it benefit all of humanity. Like, how are you supposed to do that, right? And that the default plan of being like, well, you build it in secret, you kind of like, you know, get this super powerful thing, and then you like figure out the safety of it, and then you push go, and you hope you got it right. Like, I don't know how to execute that plan. Okay, maybe someone else does, but for me, that was always terrifying. It didn't feel right. And so I think that this alternative approach is the only sort of other path that I see, which is that you do let reality hit you in the face. And I think you do give people time to give input. You do have, well, before these machines are perfect, before they are super powerful, that you actually have the ability to see them in action. And we've seen it from GPT-3, right? GPT-3, we really were afraid that the number one thing people were going to do with it was generate misinformation and try to tip elections. Instead, the number one thing was generating Viagra spam.
So Viagra spam is bad, but there are things that are much worse. Here's a thought experiment for you. Suppose you're sitting in a room, there's a box on the table. You believe that in that box is something that there's a very strong chance it's something absolutely glorious that's going to give beautiful, you know, gifts to your family and to everyone. But there's actually also a 1% thing in the small print there that says Pandora. And there's a chance that this actually could unleash unimaginable evils on the world. Do you open that box?
Well, so absolutely not. I think you don't do it that way. And actually, honestly, like, I'll tell you a story that I haven't actually told before, which is that shortly after we started OpenAI, I remember I was in Puerto Rico for an AI conference. I was sitting in the hotel room, just like looking out over this wonderful water, all these people having a good time. And you think about it for a moment, like if you could choose for a like, you know, sort of potentially like basically that Pandora's box to be, you know, 5 years away or 500 years away, which would you pick? Right? And like on the one hand, you're like, well, like, you know, maybe for you personally, it's better to like have it be 5 years away. But if it gets to be 500 years away and like people get more time to get it right, like, which do you pick? And like, you know, I just like really felt it in that moment. I was like, of course you do the 500 years. Like for real, like there's many people, like my brother is in the military at the time, and you're like, he puts his life on the line in like a much more real way than like any of us, you know, typing things in computers and developing this technology at the time. And so, yeah, like I'm really sold on you gotta approach this right. But I don't think that's quite playing the field as it truly lies. Like if you look at the whole history of computing, like I really mean it when I say that this is a industry-wide or even like sort of just almost like a human development of technology-wide shift. And the more that you sort of don't put together the pieces that are there, right? We're still making the faster computers, we're still improving the algorithms, like all these things, they are happening. And if you don't put them together, you get an overhang, which means that if someone does, or you know, that the moment that someone does manage to connect the circuit, then you suddenly have this very powerful thing, no one's had any time to adjust, like who knows what kind of safety precautions you get. And so I think that one thing I take away is like, even you think about development of other sort of technologies, think about nuclear weapons, people talk about being like a 0 to 1 sort of like, you know, sort of change in what humans could do. But I actually think that if you look at capability, it's been quite smooth over time. And so the history, I think, of every technology we've developed has been you got to do it incrementally, and you got to figure out how to manage it for each moment that you're sort of increasing it.
So what I'm hearing is that the model you want us to have is that we have birthed this extraordinary child that may have superpowers that take humanity to a whole new place. It is our collective responsibility to provide the guardrails for this child, to collectively teach it to be wise and not to tear us all down. Is that basically the model?
I think it's true, and I think it's also important to say this may shift, right? Like, we gotta take each step as we encounter it. And I think it's incredibly important today that we all do get literate in this technology, figure out how to provide the feedback, decide what we want from it. And I think that my hope is that will be continue to be the best path, but it's so good we're honestly having this debate, because we wouldn't otherwise if it weren't out there.
Greg Brockman, thank you so much for coming to TED and blowing our minds. Thank you.
Appreciate it.